All right, hello, everybody. How's everybody doing today? I hope everybody's doing fantastic. All right, apologies for the slightly late start here, but we're back on track here, no problem. All right, very good. Hopefully, everybody had a wonderful weekend. I hope everybody had an absolutely wonderful weekend. Hopefully, you did. Hopefully, you had a lot of fun this Labor Day weekend. Everybody doing good today? Hopefully that they are. We'll get started as a few more people start to trickle in. Hey, there's Hisa. Hisa, hello. How was your weekend? Good afternoon to you. Hopefully you're doing well. Hey, Anna. Hey, good afternoon to you, Anna. I hope you're doing good. Yeah, my weekend was really good, Hisa. I had a lot of fun. A lot of fun this weekend. Excellent. I'm glad you're doing well. Glad you're doing well. Well, I guarantee you today won't be too hard. I think today will be nice and easy. Easier. Possibly easier. Maybe? Maybe. Just maybe it'll be easier. We'll answer a few questions here and then we'll move forward. You saw Shang-Chi and the Ten Rings. So how was it? Was it good? Or what was your opinion? I believe that's the Disney movie, right? Shang-Chi and the Ten Rings. I heard about it briefly, so fill me in. You thought it was good? Oh, it was the new Marvel movie. Okay. Oh, you saw it? It was pretty good. Good. Glad you guys had a nice time at the theater. Not a, did you guys go to the theater or did you watch it on stream? Was it a streaming movie or was it an actual like, hey, you gotta go to the AMC to go see it sort of deal? Only in theaters? Okay. You never know with movies these days. Now that they're kind of mixed platform stuff, it looks like they want people to come back to the theater. There's one positive thing about the theater is that you get your fresh popcorn. Fresh popcorn can't be all bad. I need my popcorn. I need my pop. It's got to have some butter on the popcorn. Get a little bit of that popcorn salt. Mm-mm-mm. Outstanding. You should get one of those popcorn machines that you can buy on Amazon and stuff. That's what I'm thinking about right now. All right. I'm a fiend. I don't like popcorn. Nothing wrong with not liking something. Nothing wrong with not liking something. If you tried it, you're like, okay, well, okay. What about Angie? What about nachos then? If you don't like popcorn, what about nachos? I can at least ask that alternative question, you know? If it's not one thing, it's got to be something else. Yeah, nachos are good, okay. Now, the other question is with or without jalapenos? Pretzel bites are pretty decent, I will say that. It's got to be a good one. With jalapenos, very nice, very nice, very nice. I approve. I approve. It depends what kind of mood you're in, but you know what? Most of the time, jalapenos are the way to be. See, I will say one thing about pretzel bites. If the pretzels are too dry, then the pretzel bite just tastes terrible. You have to be careful about how dry the pretzel is. Because then it doesn't matter what you do. Like, it doesn't pair with the cheese that well if you're going to dip it, you know? Let me turn on this fan of mine. All right. Get the fan in the picture there. All right. A little warm in here. All right. Okay, ladies and gentlemen, let's go ahead and get started here. Let's start with some new stuff. I promise you we're going to get on with it. And hopefully today will be a review day for most of you. Question mark. Well, let's see. It all depends. All right. Let's do some intros. Let's get started. I need a better clap for that. There we go. Okay, let's get started today. Welcome back to Tuesday. Hopefully, I had a nice Labor Day weekend. All right, so for today, ladies and gentlemen, we're going to be doing, we're going to be moving into Chapter 3. Last time, we did talk about how to arrange data here in a histogram, did some frequency distribution, did a lot of that stuff there, looked at misleading graphs, and that's all well and good. But here today, what we're going to be doing is we're going to be doing something that we have covered here. You probably have covered many a times before. But we're going to be looking at it in a slightly different light, which is talking about mean, median, and mode. Okay, so, and then if we have a little time after that, certainly we'll be talking about a little bit more after that as well, which we should probably have time with, but we'll cross that bridge once we reach it. All right, so let's go to the big board here today, and you'll see that there are a few, it'll be a little different than maybe what you're used to here. Okay, so let's go ahead and take a look at what we see here. Now, did talk about question 1 here, so we're going to start from question 2 here and then work our way down from the previous handout. Okay, so how do we find mean? Now, I think everybody, everybody's at least done this at least once from way back in the day. But mean is just the same thing as saying average, okay? We're pretty comfortable with that idea. Average and mean are pretty much one and the same word. And all we have to do on the basic is that we go ahead and we say, all right, you take the sum of all the data items and you divide it by the number of data items, okay? So you just add it up all together and you divide by how many numbers that you got. And then there you go, that's going to be your mean at the end of the day. What's more important here about this is the concept itself. I think, like I said, we'll do a look at an example here momentarily. But the idea is not hard. However, one of the things that is in this class that you do have to kind of get to know, and one of the things I do want to introduce you to, is referring to notation. Now, notation here is going to be kind of a big deal in this course because a lot of different concepts use a lot of different types of notation. And I want you to get comfortable with this notation here because it does have a significant meaning. Okay, so let's take a good look here at what we see here in front of us. First of all, let's talk about the notation that you see on the... So what I'm going to do here is basically I'm going to write it out in words, and then I'm also going to write it out in like notational letters or whatever symbols are used. Okay, so you'll see me do this quite often here because, again, the book's going to kind of, if you look in the book here, it's going to make the assumption that you kind of know what the notation is. So again, I want you to get comfortable with this idea as we continue moving forward in subsequent sections and chapters. All right, first of all, let's talk about X bar here. X bar is the sample mean. If we talk about the sample mean, that is what that is talking about here. Now, there's also another thing, actually, yeah. There's also another notation here. Now, sample mean, you may see this, and I probably should have added that there, and probably will. Let's see if I wrote that down. So you may see this for sample mean, or copy pasta this for just a second. May actually also see this as well. So I'm gonna change this up for just a second. This thing doesn't totally die on me. Fortunately, it does not. All right. And I will state this here as well. All right. So you may see something akin to this, and let me copy this and paste this over. Okay, there we go. All right. So you may see something akin to this. So you may see this letter, this Greek letter mu, is what this is called, or u, whatever you want to call it. It doesn't really matter. But what is important is this notation here. You may see x bar, which represents sample mean, or this mu here, which represents population mean. Again, sample and population are two separate things. Okay, so they each get their own respective designations and notations associated with it. All right, so I do want to state that here first and foremost. All right. Now, you'll also get this other notation here, which is this. This is sigma here. Sigma in our math notation here represents the words the sum of all. So like it says the sum of all data items. All right, so we're just taking every data item, every number, and we add it together. Well, what does the sum of all mean? Well, that's this sigma notation that you see here. Xi represents the data item. Again, every data item is a separate data item, so X sub I is going to be a data item. And N is the number of data items in the sample or population. Technically, this should say sample or population, but it pretty much means the same thing. You can make a small change here. Technically, I guess I'll make a small change here for the population. You would label it as capital N. I guess I'll probably put that here. I'll put that here as well, just for sake of posterity, because, you know, I'm a boring old fart, and that's what I do. Alright, let's put it this way. Take it one more step after that. Alright. So that's fine. So you may see, for example here, capital N being population size. Again, if you do see that, that's not going to be anything brand new. But again, the formula here is pretty much the same, depending on which context that you work over. Now, let's go ahead and take a look here at an example here. And so we're going to use this example for the other two, but at the very least, let's just see what we're working with here. All right, so for this one here, let's use a stem and leaf plot. Okay. So let's make up some numbers here for the stem, and let's make up some numbers here for the leaves. All right. So we got this, and see 0. Go with 4. We'll go with 5. We'll go with 9. And we'll go with 3. Go with 2. Go with 8. And we'll go with 9. 13. 1. 6 and 7. All right, there we go. All right. There we are. All right, perfect. So these are just some random numbers here. Now, just to give you a friendly heads up here. Again, 03 represents just the number 3. Okay, 06 is just the number 6. Okay, so again, 1 would represent 11 at the end of the day. All right, so just letting you know how it works. That's pretty much how you're going to view it. Now, of course, if we're trying to find mean here, let's say this was part of a sample, for example here. So again, we're just going to take all these guys, okay? We're going to add them up together. Let's find that mean here. So 3 plus 6 plus 11 plus 12 plus 12 plus 17. Let's see here, plus 20 plus 24 plus 25 plus 29 plus 32 plus 38 plus 39. plus 41 plus 46 plus 47. And we're just going to divide all that stuff by, let's see, 8, 10, it's like 16. So we got 16. All right, so now using your calculator here, do I want to become famous? Oh, yes. I think you want to become famous, my friend, by getting banned. Bye. All right. All right, so anybody tell me here, what is the answer to this problem here? What is the answer to this problem here? Again, use your calculator here. Add all those up together, and tell me what you get here. Again, type it out in chat once you have your answer there. All right, don't forget to go out to 4 decimal places there. All right, so we got 25.125. Okay. So 25.125, is that what everybody else got there? Hopefully it was. Okay. Again, if you don't have your calculator out, this would be a good time to take it out. So excuse me. All right. All right, you got that too? Perfect. All right. Good. Excellent, excellent. All right. So that's our mean here. All right. So our sample mean, or whichever type of mean that we're working with, that'd be sample or population mean, 25.125. All right. Seems fair. Very reasonable. Easy peasy. Okay. So that part, not too hard. Okay. Next, let's talk about the next part here, which probably is the toughest of the three, but again, still needs to be talked about. That talks about median. So let's talk about median. Okay. Okay. So median here, how do we find median? All right. So before you do anything talking about median here, anything that you do, the first thing that you always have to do is you always order the data set before you find the median. All right? So you always order the data set. So as you can see here in this data set, I put everything in numerical order. Okay, so for example, 3 and 6 and 11, 12 and 12, 17, 20, and so on and so forth. Okay, so I've already put it in numerical order. But if it's not in numerical order, you'll need to do that first before you go ahead and find the median here in any case. Okay. All right. So what we have here is we have 2 steps that we need to do in order to find the median. What's the first step? All right. So let's talk about step 1. Actually, I probably should put that there. So let's look at step 1. Step 1 here is to first find the position of the median. All right. All right, so find out where the median will be located. See, it's easy for us to say, well, the median is located in the middle. And I'd be like, sure, I don't disagree with that. Okay, by far and away, you're correct. The problem is to define what middle means. Because, of course, in maybe our example here, this is a basic example, where finding the median, you can pretty much map it out just by kind of pointing your finger around. But what happens if we have a data set that's thousands of numbers long instead of just a simple 16? Well, then we're going to run into some issues that are going to be very problematic. We want to be able to go ahead and find exactly where that position is so we can avoid doing all that work and not look through thousands of numbers. We just want to find out exactly where it's located, and then we can proceed to do what we need to do from there. Okay, so how do we find that position of the median? Now, the position of where this median is located is going to equal n plus 1 over 2, where n is the number of data items in the sample or data set, or whatever you want to call it. Okay, so at the end of the day, that's what essentially we want to do here. Now, we'll also talk about step 2 here since we're already there. So step 2 here is to basically find the median, okay? All right, depending on the scenario. All right, so find the median depending on the scenario will be the second one here. So here's how it's going to work. We found the mean, that's great. But now we put it in order here. We want to find the position, and after that, it's now going to be determined based on if the number of data items in the data set is going to be odd or is it going to be even. Okay, so if n is odd, then the median can be found exactly at the position that you find it at here in step 1. If n is even, then the median is going to be the mean of the two numbers around the position that you find. Let's go ahead and take a look and see what that looks like. Okay, now first and foremost here, let's go over step 1 here if we're going to find the median. Okay, so this is the median part here. So let's look at step 1. Step 1 is we have to find the position of the median. So can anybody tell me here, what is n going to be? How many data items are in the data set here, according to what you see here in the example? Anybody tell me? Data items in the data set. Okay. Good. The answer is indeed 16. All right, so we're going to do 16 plus 1 divided by 2. All right, that's what we're going to do. So here we do 17 divided by 2. 17 divided by 2 is going to be 8.5. Okay, so where this median, again, 8.5 is not the median, but it's where the median is located. Okay, so we're going to look at the 8.5 position according to our data set here. We're going to look at the 8.5 position here. So I'm going to mark it in red. Okay, put a little arrow where that's going to be located. So let's take a look here. So we get 1, 2, 3, 4, 5, 6, 7, 8, 8.5. So 8.5 would be right here. Okay, so 8.5 would be located right there. Now, admittingly, there is no number in the 8.5 position. That's not realistic, okay? Clearly, there's no number there. But let's go back to our scenarios now, okay? So what we did find is that, well, what happens if we run into this case? Well, the way we find our median is we take the mean of the two numbers around the position found. So where this arrow is located, it's between the numbers here of 24 and 25. So we're just going to go ahead and take the mean of those two numbers and then see what we get. So 24 plus 25, and we'll just simply divide that by 2. And so here we get 24.5. All right. All right, so that is the median there. Are there any questions about that? Stash like, no. No, lol, no capital. No cap. No cap. All right, that's fair. Okay. All right, so let's talk about median here in a little bit more detail regarding in statistics why median is so useful. All right, so let's go to question 4 here. Why is median better than mean? Why is median better than mean? Now, I did put an answer here, but I need to demonstrate this by using a simple picture. Whenever you talk about median here, one of the things that's most important is people get the idea that average is like your benchmark for a lot of things. Okay, like you should look at average, and then that's what your expectation should be in a given situation. And that's not always true. In fact, median is probably the better of the two expectations to actually have. Let me give you a simple scenario, and you'll see why it's applicable in a lot more situations than just this one, but still, at least a simple one just to showcase what it's all about. So imagine, if you will, imagine that you had a neighborhood. All right, and let's say there are 3 houses in this neighborhood. Okay, only 3. It's a pretty big street, but there are only 3 houses. All right. Let's say you have the first house here. Let's say the first house is pretty dilapidated. Okay, needs a lot of work. Kind of pretty run down, woods rotting everywhere. But the price is pretty outstanding. It's a good fixer-upper. So maybe it costs you $10,000. Okay, so maybe 10K, $10,000 for that first house. All right, we'll put 10,000 actually instead of 10K. Easier. Okay, let's say there's a second house. Okay, let's say there's a second house. Now, it's a little bit nicer looking than the first house, but it's still pretty run down. It's still a pretty good fixer-upper. It's got the boarded up windows just like the first one. But hey, you know what? Put a little money, put a little love and shine. It'll look great. But it's worth just a smidge more at $20,000. Let's say let's take a look at the third house there. Let's say the third house is pretty brand new. Pretty shiny looking house. It's a big old mansion. All right, it's got all the goodies. And let's say this is worth 1 million. Okay, so we have $1 million mansion here at the end of the block. Okay. Now, if we were to take a look here at the average price of the houses in this neighborhood, on this block, whatever you want to call it. Okay, the mean price of the houses here, you would take all 3 of those values, you would add it up together, and you would say, well, the average price of the house in this neighborhood is over $333,000. Okay, be like 333,300, whatever, don't matter. Okay, but it's over $333,000. Now here's the problem. The problem is that if you look at all the houses in the neighborhood, which of which there are only 3, the majority of the houses do not reflect $333,000 worth of property value, not even remotely close. Right? That's just not a possibility here. Okay, that doesn't happen. However, if I were to look at the median instead, well, what's the house that has the middle value? The house that has the median value here is $20,000, which is a better reflection of what the entirety of the neighborhood is all about. Again, you have 2 out of the 3 houses which are not worth a lot of money, and you just have that one house that basically skews all the data in one direction. So that's the one thing you don't want in your data set, and that can happen, of course, where you have an extreme piece of data, okay, one that is completely off the chart, okay, and if it's so big that it basically skews the rest of your data, well, then the mean's not going to mean, well, literally anything. So what we say is, let's say the median here is more resistant to extreme values than the mean. So in a practical setting, if you talk about salaries, okay, like, hey, you were going into the workforce here with very little experience in your field, you need to not look at the average salary of that worker. You need to look at the median salary of that worker, because the median salary will give you a more realistic expectation where it's not being influenced by people who make an extreme amount of money. Especially, say, for example, if you go into a field like, say, computer science, and you say, well, what's the average salary? The problem is you could be running into people who are senior designers in management positions who make a very large quantity of money, but in reality is not reflective of what the industry will actually pay you out of the gate. You want to look at the median salary and then see what your expectations are, and you'll have a pretty good, clearer picture about what you should be looking for when you walk in the door. Because if you ask too much, well, then they're just not going to hire you. So you don't want to push your luck either. You don't want to undersell yourself, but you don't want to oversell yourself either. So in terms of how much money you want, because then they're like, well, can't afford you, have a great day. So gotta be careful to play around with that. All right, so there's that. Okay. Questions about that before we move forward? Any questions? Again, type no in the chat if you have no questions, and I'll move forward. And if you do have a question, please go ahead and type that out too. All right. Okay, let's talk about the next thing here. We'll move forward. Let's talk about the next thing here is talking about mode. All right, now mode here is something you've heard about before, but let's talk about it in a little bit of greater detail. We'll look at the example, of course. So mode here is the data item or data items that occur the most often in the data set. Now there are rules here in regards to mode, so let's talk about those rules here. The first rule here, and when it comes to mode, is that the mode must occur more than once in the data set. So the mode must occur more than once, meaning if it occurs just one time, it doesn't count. Okay, that means that no, that's not a mode. It has to occur more than one time, otherwise it's a no-go. So they only occur one time each. Too bad, so sad. Now, of course, that has some consequences. The first consequence here is that there can be multiple modes. Okay, so there can certainly be more than one mode. All right, you can have many modes. Okay, you can have 2 modes, 3 modes, whatever the case may be. As long as each of them occurs at least the same amount of times and occurs more than once, then you're good to go. And the last thing that can happen here is that it is possible to have no mode. So it's completely, entirely plausible to have absolutely no mode. All right, you could go through everything and you could have no mode at all. All right, so that's certainly possible in a given data set. So let's take a look at our example here. So taking a look at our example here, what is the mode of this data set? What is the mode of this data set that we see here? Can anybody tell me, what is the mode? What is the mode of the data set that you see here on screen? I'll see if you guys can get it here. Okay. All right. Very good. All right, so that is definitely the answer here. The answer here is definitely 12. All right, 12 is the correct answer. So as you can see here, 12 is a number that occurs twice in the data set. So 1, 2, 1, 2 for 12, 2 times. So again, it does qualify to be a mode, and it's the only number that occurs more than once actually within this data set is the number 12. So that's it. That's it. That's the mode here. We just have a singular number here. That would be 12. All right. Seems fair. Okay. Any questions about mode? Again, I think for most of you, you've probably seen this before many a times, and it shouldn't be anything brand new. That's pretty much how mode works. Nothing too crazy, I promise you. Questions, guys? Any questions? Okay. No. All right. Alrighty. Let's take a good look here at the last part. Now, the last part here is probably the most boring question in this course. It says, how do we find range? Well, that's pretty easy. All you gotta do for range is you take the highest data item and then you subtract it from the lowest data item, and then, yeah, that's it. So, yeah, I know. I ain't gonna lie, it's so boring. They asked this question here, I'm like, why? Why are you doing this to me? Why do you make me do things, book things, please? I don't want to do it. You know, that's how it is. These questions are already, well, all the handouts are in D2L1. They have been there since the beginning of the semester. The only thing is that they're not filled in. I fill them in as we do the lectures and stuff. So you follow along with me. So if you look underneath content in D2L, and then you go to the handouts, you'll find them. All right, so you get 47 minus 3, and you get 44. Yeah. Yeah, great job, everybody. I ain't even going to bother to ask you if you have any questions, because you shouldn't. And if you do, sadness. I'm going to be sad. Take biggest number, subtract smallest number. Oh man, so hard. Okay, good. Oh my goodness. All right. Okay, so there's that. All right. Now, that's me. That's mean, median, and mode with range. Fine. That's all great and good. Now, we are going to look at something a little bit more different. Now, the next thing we're going to talk about here is going to be a very important topic that will be seen throughout the rest of the course in some capacity. And we will need to discuss it for certain because it is something that we do use quite often in many different topics. So it's on us to go ahead and explore. So the next few questions, and I don't mean just the next question, but the next few questions have a lot to do with each other. So we're going to use 7, 8, and 9 here are going to go together. And so let's talk about 7, 8, and 9. We're going to spend a majority of the time here on these three questions. So let's talk about them now. All right. First of all, number 7, number 8. Talk about population variance and sample variance. Okay, so how do we find population variance? How do we find sample variance? How do we go ahead and use those here? I don't know why I have it like this. It should not be like. Hang on a second, folks. I put the wrong thing for that. To change that up. I swear I checked this and then it's like, well, still don't got it right after all that. There we go. Should look like. Okay, so here is population variance. Here is sample variance. Now, I do want to point one thing out here. Oh, did my did that just go blank? Hang on. Did you guys just did it black out on you guys? I don't know if did the stream just black out on you guys or no? Blacked out on my screen. No? Okay. Alright. Good. I'm not going crazy, alright. For a moment it was black and I'm like, oh no. Can you guys not see what's going on? Okay. Okay. Sorry about that. Sorry about that. Had to be a double extra sure. Like I said, if there's issues about the stream, if your stream's a little slow, refresh and see if you can catch up to the stream. Hit F5, or if you feel that the stream is slow, or if there's issues going on that I can't see, then just let me know, and we'll work things through. All right. In any case, let's go ahead and take a look here at why did I put this? Anyway. Let's go ahead and take a look here at population variance and sample variance now. If you take a look, first and foremost here is the notation, all right? So as we talked about here, we talked about this mu, which was population mean, capital N, which was population size. I just labeled this as X as data item. I know I could have put X sub I. That's perfectly fine. Now let me point out one thing before we continue moving forward here. Am I expecting you to memorize these formulas? The answer is absolutely not. Okay, what I would like you to do is to be able to apply them. We're going to see how we can apply them to find these particular guys. All right, so again, it's not a matter of memorization, but it does have, but what we see here on this page anyway for 7 and 8 will have a lot to do with the next question. So hence why I'm writing down these formulas just like so. Okay, so we're not getting into too much detail here regarding variance, but I am putting down here the notation that hopefully you'll be getting used to here as time moves along. How do we find sample variance? Now, sample variance, the notation here is S squared. Again, it looks pretty similar to that of number 7. It's just the data item minus the mean, minus the sample mean, divided by the sample size, minus 1. So notice the difference here. Population variance, you're actually just dividing by the population size. Here you're dividing by the actual sample size subtracted by 1. So a significant difference between the two, at least from what you're dividing by. Now, why are these important here? Let's talk about that. Okay, so more importantly here, you're like saying, well, this is really different than what I'm used to, because maybe mostly what you're used to is mean, median, mode, and range, and all those guys. But this is where we actually use statistical analysis. This is the first part where we actually where we're applying our statistical analysis. Because what we get from variance is what's called standard deviation. And so for the remainder of the class here, we're going to talk about standard deviation, how to find that here. Okay, so let's go to question 9 here. And then we'll do stuff together here. How do we find sample standard deviation or population standard deviation? Now, if you talk about sample standard deviation, first of all, I want you to note the notation here, which is the letter S. That letter S that letter S is by design. Why? Because the notation for the sample variance is S squared. The notation here for sample standard deviation is just the letter S. Well, how do you go from S squared to S? You just take the square root. That's why you see it's the square root of just this previous guy that you see right here. All right, that's all it is. Just the square root of that previous sample variance is what we're getting used to here in this case. So there's the sample variance over here to the upper right. There's the sample standard deviation bottom here. Now, what exactly does sample standard deviation or population standard deviation or standard deviation in general, what does that mean? All right. Basically, what we're looking at here is how far away on average data items are from the mean. So as a formal definition, that's what it is. We look at all the data items and we say, well, how far away on average are the data items away from this mean here? Again, a larger standard deviation would represent numbers are pretty far apart from each other. That's a pretty wide data set. If you have a small standard deviation, meaning you have a pretty narrow data set, okay, it's kind of centralized around the mean there. Okay, it's not very much lateral movement between numbers, if you want to kind of call it that. Okay, and we use this in a lot of different calculations, guys. A lot of different calculations. Okay, so this is something we're going to see over and over and over again. All right. Now, population standard deviation probably works the same way. Again, you see this letter rho. It's the square root of the previous sample population variance. Pardon me. And all you have to do is take the square root, and you get your population standard deviation. However, now we could do this by hand, and doing it by hand is all well and good. But it's going to take us some time to go ahead and do that by hand. You basically, if you're going to do it by hand, you would take literally every data item, subtract it from the mean, and then you square it. Then you add all those guys up together, and then you divide it by how many your sample size, or subtract it by 1 or not, and then you take the square root of that. And as you can tell, even describing the process sounds like it takes a bit of time. Fine. What we're going to do here, we'll streamline the process here to find the sample standard deviation or population standard deviation. I'm going to go ahead and use the calculator for this here. This is going to be our first foray into using the calculator to find both types of standard deviation. And from that process, we're going to be able to also find the variance that goes along with it. All right, so let's go ahead and do that right now. Okay. So, yes. Actually, second here. Come back to this, but I'll just write this in. All right. Okay. Now I'm going to put this on a half and half thing. Actually, I'm going to put it on this half. Alrighty. So next what we're going to do here is I want everybody here to take out their calculator. Alright. And we're going to go through this very, very slow. Okay, so we're going to take our time here because I want you to get comfortable and used to using the calculator in a proper capacity. So I want you to go ahead and do that here right now, is to be sure to take out your calculator here. So I'm going to put the calculator up on screen. And once you have your calculator out in front of you, okay, your graphing calculator here, please type in done in the chat. And so that way, again, I want everybody to be on the same page here. So please type done in the chat if you have your graphing calculator out in front of you. Okay. Give you guys a minute, just to try and grab your stuff there. So, and I just want to be sure again. I know some of you don't really talk in chat, but this is like one of those times where I'm going to ask you to, because I want to be sure that everybody's got their equipment and stuff, because I'm going to go through this step by step very carefully. All right. Again, type done in chat if you have your calculator with you. Your graphing calculator in front of you. We're going to go through it together. All right. I'll wait another 30 seconds or so, making sure. Again, type done in the chat once you have your graphing calculator in front of you here. All right. Go through this together here. Okay. All right. Okay, so I'm going to go ahead and get started here. All right, with the calculator portion here. All right. So the first thing that I would like you to do here is, if we're going to find the standard deviation, we're going to find our variance and do all that kind of stuff. All right, so the first thing that we're going to do here, ladies and gentlemen, is we're going to go ahead and hit the stat key here. The stat key is located right where my mouse is circling right now on this calculator on the left-hand side of your screen. All right, so we're going to hit the stat key here. We're going to get to this menu right here. So again, I'm going to go to stat. And then we're going to go to edit, that very first thing that you see here on the screen. We're going to hit stat, and then we're going to go to edit. Okay. And then this is the screen that you should see right now. So you should see these lists here. Now, if you have an old school calculator, you may see only 3 lists. This is a fancy schmancy software. If you have a new school calculator, you may see 5 lists. Whatever the case may be, there may be some numbers in there. If you had a hand-me-down calculator, that's just fine. We're going to go through that process and getting rid of those numbers as well. But before we do any of that, I want you to type done in the chat if you've made your way here. Made your way to this little menu here. If you made it to your list, hit type done in the chat. Remember, if you're having trouble, just let me know and I'll say it again. Make sure everybody's on the same page here. All right. Okay. All right. Now, if you do see numbers here, like I have on my screen, because I used this for a previous example in another class, if you do see numbers here in your calculator, there's an easy way to get rid of them. All right. What you want to do is you want to hit the up arrow here. If you do see numbers, again, for those who have it, you're going to hit the up arrow. You're going to highlight the list. You're going to hit the clear key. Okay, you're going to hit the clear key. Okay, do not hit the delete key. Okay, please, for all the love that is holy. Okay, please, do not hit the delete key for heaven's sake. Hit the clear key and hit enter. All right. Hello, Ahmad. How are you? Well, welcome. You want to hit the clear key, you want to hit enter, all right? So that will clear out your list there. That'll clear out all those numbers if you have any numbers put in there. Okay. Next, what we're going to do here is if you see all these numbers in our data set, we're going to go ahead and put all those numbers into our first list that you see right there. So we're going to just go ahead and enter in all the numbers here. So 3, 6, 11, 12, 12, 17, 20, 24, 25, 29, 32, 38, 39, 41, 46, and 47. So you should have 16 numbers just like we talked about before. Okay, you should have 16 numbers just like so. Okay, so just want to point that out just like so. Mod, you're always welcome here anytime. All right. Okay, then make sure everybody's got their numbers put in. And type done in the chat once you have those entered into your graphing calculator. Got a few people done. Let's see a few other people here. Again, I just at the end of the day, I just want people to be on the same page. I know some people take more time than others, and that's perfectly fine. Okay, so we're being patient through this process here. Okay, I know that with the calculator, it's a little bit more difficult to use. Okay, especially with a piece of machinery that can be confusing. So that's why we're going through this slowly. Want to be sure you guys get comfortable with using the calculator. in a more advanced capacity. All right. If anybody's having any issues, please let me know, and I'll be happy to guide you again. So, all right. Now, one of the things I will say here, I'm going to make a couple of disclaimers here really quick. One of the things about the calculator that is very, very true, it being a graphing calculator especially, is that the calculator is very, very picky, and I mean extremely picky. Okay, so again, if you enter something in wrong, it's going to, tell you, blah, this thing is an error, or it'll give you the wrong answer. Now, again, these are important things to keep in mind. So one of the things that I like to do, and what makes a very good habit here to do on the calculator, is to make sure that we don't enter anything wrong in these lists or otherwise for what we'll be doing later. So what I like to do, and what should make it a good habit for you moving forward, is we're just going to quit to the main screen here. So in order to do that, we're going to hit the second key, we're going to hit the mode key. Okay, so the second key and the mode key here, we'll just quit to the main screen here. What this basically ensures is that anything in our list is already as is, and then we're not entering in anything else bad into that list, okay, where we're going to get nasty errors later on. All right, we've saved it. It's saved just like so, so we should be copacetic right then and there. Okay, got to the main screen. Great. Okay, now let's talk about what we're going to do next. Okay, so once you're back in the main screen after hitting second in mode, we're going to go ahead and go back to our screen here. We're going to go to stat, hit the stat key here, but this time, all right, this time we're going to change things up a bit. We're going to go to stat, and we're going to go over to calc. So we're going to hit the right arrow here. Instead of edit, we're going to go to right arrow here. We're going to go over to calc. So we're going to head off into this menu right here. Okay. And then I would like you to select, of course, there is a certain one I would like you to select, which is going to be that very first one that you see there, 1 var stats. Okay. 1 var stats. So we're going to hit number 1 and 1 var stats. And so I'm going to go ahead and show you. This is what you probably will see. Don't worry about what you saw there, and just we'll reach that bridge when we cross it. But this is maybe what you do see here when you hit 1 var stats. So, oops, add that. Go. Okay, so this is maybe something you see. You may see this sub menu here. Now, before we move forward here, I need to get a good gauge about everybody here. All right. How many people see this screen here? Just type me in the chat there if you do see this screen, because you have a new school calculator. Okay. All right. Good. Good. Okay. Okay. Good. Good. All right. How many people on their screen? How many people have the old school calculator where on your screen right now, you just see on the top of the blank screen, you just see 1 var stats? Anybody have an old school calculator? Anybody have the old school? Type, yeah, you can type I do if you have the old school calculator. If you have the old school calculator, type I do, and then, okay. Good, good. All right. I just wanted to see what the difference was, how many people have and how many people don't. Okay, so here's what I'm going to do. This is why I asked this question, because it is important to me in this regard. That is, I understand that, like people like Anna or maybe other people, maybe watching these replays or whatever, they may have the old school calculator. Like my calculator, my actual physical calculator, is a super old school calculator. Like this calculator is like 9-10 years old that I found at college one day. So this thing is like super duper old school calculator like this. Now it does the same thing as yours, Anna does. So that's perfectly fine. If you have some questions about math, I would just ask you to remain patient here. Uh, but so what you'll see on the top of your screen is one bar stats. So that's the old school calculator. Many people have the new school calculator. Maybe they bought it for like $100 or something, and then they have they have what you see here, this sub menu here. Now, what I like to do here is I like to go through both the old school calculator and the new school calculator way. Okay, so I like to do both. Okay, so that way, because in the old school calculator way, they don't tell you what the formatting should be. All right, and even with the new school calculator, they don't tell you exactly what to enter in to the calculator, so you have to be really extra careful about that as well. Okay, so I'm going to go through both here. I'm going to show you both here. I want to be sure that everybody's taken care of when it comes to using a piece of machinery like this, again, using those advanced functions there. So trust me, Anna, I'm not going to leave you. Not going to leave you behind. I'm actually going to go through both types because I know how confusing it can be. Okay, I've been there. I've done it before many a times. Want to be sure that nobody's left behind in terms of calculator button presses and stuff like that. All right. I did want to put that disclaimer out there as well. Okay. Now what you see on here is if you have the new school calculator, you see the submenu that looks like this, which says list here. Now list here will be defaulted here to L1. Now let's say if this was blank, for example here, and this is for those people who do have this, let's say this was blank. What you want to do is you want to put in L1. If you want to put in L1 or a different list, you can hit second and 1. That is for L1, okay? So second and 1 will be L1. Again, you don't have to do this if you don't want to, if it's already there, but still, just in case, it's important to know because we do use it from time to time. All right. And then we want to go ahead and go to calculate. All right. So this is what you should see here on your screen. Now, for you, Anna, or others who are using the old school calculator way, how is it going to work for you? Well, for you, that's going to be working. This is what you'll see here. So I'm just going to get rid of this for just a second here. So what you'll see here on your screen is you're going to see this. This is what you see on your screen. You just see this, one bar stats. What you'll need to do is you'll need to actually physically enter in the list here. So what you'll need to do is you'll see one bar stats on your screen. Okay, like so. And then I just want you to hit second and the 1 key. And then you go second and 1. And then so you should have one bar stats L1. And then this is what you should end up with. So hit enter after that. They have different second differentiation. Second implicit differentiation, Ahmad. Second derivatives aren't too bad. Second implicit differentiation can be a mess. I ain't gonna lie. All right. I want you to type in done in the chat if you see the exact numbers on your calculator that you see here on the screen. Type done in the chat if you have these exact numbers appear here on the screen on your calculator. Oh, good. Good, good, good. Everybody's been able to follow along here. Anybody having issues, then let me know, okay? Just let me know. Want to be sure that, again, everybody's being on the same page here, so... All right. So, let's take a good look here at what our results are based on the calculator. All right, so we've done everything we possibly could here. Now, it should be interesting for you guys to note here. Remember that the mean here for this particular data set was 25.125. take a look at the top. Here's the mean, x bar, right? The sample mean, 25.125. It's exactly as it was set out to be. All right, so again, it tells you did it right. All right, definitely. Now, you also have one other thing here that's pretty important. We found the median here to be 24.5. You actually hit the down arrow here. You can hit the down arrow. You see how this says the down arrow here? You can actually scroll down here. And you see here MED. MED references the median here of 24.5. That's actually what we found earlier as well. So that's definitely correct, okay? 24.5. Now, the two things that we want to look at here specifically is going to revolve around these two guys, SX and rho X, okay? And these two guys here are going to be your particular standard deviations. So what's your sample standard deviation? It's going to be this SX here. Again, that's one of the notations. So the sample standard deviation here is going to reference, again, 14.3289. Okay, again, we go to 4 decimal places here. And the population standard deviation, which is that rho X, okay, which is going to be equal to 13.8739. All right. So that's going to be the standard deviations for the data set, again, with these random numbers put in place, of course. But again, that's the standard deviations here. Now, that doesn't completely answer the question here, because although we found the standard deviations, which is the main part here, don't forget we also had the questions here for variance. What do we do for variance here? Well, for approximate variance here, then all we have to do is we could either take the full length of the, probably we could take the full length of the, we'll do that here. Actually, I'll put it down here. Sample variance. All right, we could take that full number there, that 14.328. Man, I can't do 887528. And all we have to do with that is just square it. So we're just going to square the sample standard deviation, again, with its full length form, not its rounded form. Population variance. Pretty much the same thing. Again, take that deuter and 13.87387383. And we'll go ahead and square that. I'll go ahead and do that right now. So 14.887528. Square that. Oh. My bad. Insert that. Alright, so here we get 205.3167. Alright, and then we could do the next one here, 13.873. 87383. We'll square that. 192. Get 192.4844. All right. Okay, and there we go. We got our variance from that just as well. Okay, so that it's not intended to be super hard. Okay, again, it takes a little bit of work, but it's not overtly too bad to do. In all honesty, it's actually relatively straightforward. In my humble opinion, relatively straightforward. Okay. Any questions about that? Hopefully that was pretty informative. Question mark. Was that easy to follow for you guys? I hope that was easy to follow. Want to be sure that you guys get comfortable with the calculator, so if you have questions about the calculator, just let me know, okay? So we're here to go through it together, so that way we get you more comfortable with using it. So I hope it was easy to follow. Just let me know if it was. If it was, great. Then I'll just continue doing it that way, where I'm just kind of breaking it down real slow, like. So. All right. Okay, so that is where we are going to stop here for today. All right, so that's where we'll stop here for today. Next time, we're going to finish off this section here for section 3.2. Okay, and then we'll get into section 3.3. But this is kind of like the main part here about what I want to discuss here today. So get you more familiar and comfortable with what we're doing here with the calculator. That's the main focus of what we're doing today, and talking about an important topic, especially on standard deviation. All right, great job today. All right, let's go to the big cam. Cam, where are you? Big cam. All right, there we go. All right. All right, so I want to thank everybody for coming on out here to the stream once again. Absolutely fantastic, everybody. You guys did a great job here. Thank you for participating here with the calculator stuff. We'll need a little bit more here with the calculator, more than likely here for next time as well. So again, we're obviously not done using the calculator here, but the rest of chapter 3 will also be using it in some capacity for sure. All right. Maybe not as heavy of a capacity, but still in a different capacity maybe. Are there any questions? Any other questions? Does anybody have any questions before we head out for the day? Any other questions? Does anybody have any other questions? All right. Good. All right. Good beans. Good beans. All right. This is good to hear. All right, everybody. Thank you again very much here. All of you are very fantastic. I love you all. All of you make this class absolutely fantastic and exciting. All right. Thank you very much. We're going to come back here on Thursday. All right. All good indeed. All right. So we'll come back here on Thursday, same time, same place, everybody. All right, everybody, have yourself a very fantastic night. Have a fantastic night, everybody. I hope you enjoy yourselves. All right. Yeah. And we'll come back in a couple days and we'll keep on moving, all right? All right. Would I recommend us to change the modes in the calculator? No. Keep it as is. There's no reason to have it. The only mode you ever change on the calculator is probably radian and degrees, but we're not using that in this class. I promise you that one. No, keep it everything as default. You should be fine. All right. Just fine there, Juan. Just leave it as is. Okay, everybody. Thank you very much. You know where to find me here. You can find me on Discord. You can find me on, again, email me if you have questions. I will be there as well. All right. Everyone, take care of yourselves, and we will see you later. Have a wonderful evening, everybody. All right, and as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right? We'll see you in a couple days, everybody. have a great one. Take care, everybody. See you later. Bye. Bye, everybody. We'll see you later. I guess I have to do the other one.